gosh. So we're having to record this on my iPad, a little bit different than recording on the main screen because my main computer is going to die. And I said, oh, we still have to record. So we're sitting family style around the table and doing section 501. Chapter 5.
What you're most thankful for.
I am thankful.
Okay, all right, we're done. Okay, chapter 5 is a lot of... Chapter 5 is a lot of analyzing graphs of functions using derivatives. We'll do like first derivatives. We'll do second derivatives. We won't ever do anything beyond a second derivative, so third derivative is not a thing. We will do first derivative, second derivative, and that'll tell us stuff about like, is the function increasing? Is the function decreasing? Do we have a max or a min? So here we're talking specifically about extrema, which is the maximums and minimums on a graph. Okay, so max and min, put that at the top. And I'm going to talk about maxes and mins, okay? You can have different kinds of maxes and mins. Let's say, for example, I'm going to do a quartic function, and we're going to say it looks like a W like this, okay? All right. This is going to be the graph of a function on an open interval, and what I mean by that is that the interval continues on to the left and on to the right forever, okay? Does that make sense? Open interval, all right? We have, this is a min. This is a max, Emma. This is a min, okay? We have a min, max, min, okay? When we have a W that's looking like that. This is an open interval. It's going to the left and to the right forever and ever and ever. That's why I drew the arrows, okay? So we have two mins and a max, okay? We do have an absolute min, and that is absolutely the lowest point on the graph, which is that lower one of the two little points on my W. Okay, that's an absolute min. If it's not an absolute min or an absolute lowest point, it is called a relative min, which means in relationship or relative to all the points around it, it is a low point, right? This maximum right here, is that a relative or is it an absolute?
Absolute.
Relative. But these are all higher than that.
Relative.
So it's relative. It is relative. Okay? Relative max. Got it?
Got it.
Okay, that's an open interval.
Have
So it does not have an absolute. And you can you have two absolutes?
No.
Yes, if they're the same.
Like if I have my W that's the same right here and these two are on the same level, right? Those would be two absolutes.
High and an absolute low?
You can have an absolute high and an absolute low. We're going to talk about that right now.
Circle.
Okay?
Circle.
So no.
That is my homework.
No. Okay, Marcus just asked, can you have an absolute high and an absolute low? You can on a closed interval.
Can you not do
okay?
anything?
On a closed interval, let's do like, I'm going to do a cubic function. Let's do like this guy right here. Okay, closed interval, which means those two do not continue on forever. Okay, and when we have a closed interval, this is obviously a minimum. This is obviously a maximum. What kind?
Those are relative.
These are both relative, right? Relative max, relative min. Okay, now, this guy right here is also considered a maximum point because it is an actual point on the graph. This one is going to be a maximum. What kind? He is going to be an absolute max. This guy is going to be an abs min.
Not girls.
Okay, I don't know. Okay, absolute max, absolute min. So when you have a closed interval, you do consider the left and the right endpoints to be points on your graph. Okay, does that make sense? Here we're not looking at these 2 points. Got it? Questions about that? Extrema. All of these are extrema. Maxes and mins. Whether absolute or relative. Got it?
Yes.
All right, I'm going to skip this box. Definition of extrema. We're talking about mins and maxes and all that good stuff. Whatever. Okay, let's go down here to their graphs. These are all closed intervals. How do I know that?
Because they're also.
Okay, this is a dot and this is a dot, but also it says this guy right here. When you have brackets, that means he is closed off at those points, okay? So that is a closed interval. We have a maximum here. We have a minimum here. We actually have a maximum here as well, right? That would be a relative max. Here, I think when they're labeling, they're only labeling the absolute one. So this is an abs min. This one's an absolute min. This one is a relative, or excuse me, absolute max, absolute min. This is a relative max. So they only labeled the maximum and minimum as absolutes.
Are the open circles.
Are the open circles. So in the second one, Are the open circles
Oh, it
going
says
to be
not
anything?
No.
No. So that is not a physical point. That is not a physical point. So here we only have a minimum. What kind of minimum is it?
Absolute.
That's an absolute.
Would it-
Well,
Okay.
could you say
yeah.
that there's a maximum right below that
No,
point?
because we don't know. Like, okay, if this is at 5 right here, do we go with 4.9? Do we go
No,
with
you say
4.99? Do we go with 4.999? Like, is that my whatever, right?
Hey,
I don't know. So
at
we
this.
just don't label it at all.
Look at this.
Nope, we just don't label it at all
I know the
as the
first
highest
one
point.
Wait,
is
wait.
pi.
Look
It's
at
memorized
this.
in
Look
my
at this,
brain.
okay?
Yes, ma'am.
I want to know
Is
the
this, so there's a
first
thingy right here, okay?
You want to hear the first
That's
20?
the absolute
3.141592653589.
minimum, right?
2653589.
Yes, but this one, if he's just like
First 20, look at
flattening out at that point, he is neither.
Marcus, do you know
What?
the preamble?
Okay,
What if there's
right
a
here.
point there?
This is what Emma just asked.
Preamble
This is a really
to the
good question,
Constitution
actually.
of the United States of
So
America.
here, like this is a cubic function where he's not like humped up or down. This is a point of inflection. Boys, you're listening to this. Shh. Hey. Just in a cubic function where he doesn't like sometimes cubic functions will do this, right? Where you have a max and a min, okay? But this one does not. This one is not a max or a min. It's actually a point of inflection, which is where, and we learned that in trig class, okay? It's a POI. A point of inflection is where he changes concavity. So this is caving up.
Whoa, that's a big word.
This is caving down,
Concavity.
right?
Have you
Okay,
ever had any
concavity, concave
concavities?
up and concave down.
Yeah, because I grind my teeth
So
in my
there's that.
sleep.
You
Anyway,
get concavity.
so sometimes you will have a
I've never
place
had
where
a
he looks
concavity
like he
either.
might be a
Have you
max
had
or
a
a min, but he's not.
concavity
Okay, here we go. This one. This is not a min because he has a circle or an open circle. This is a max. This is an absolute max. Shh. This dot right here is a
Relative max.
relative max.
Then I went
So
to
you
my
felt
other
Okay.
better?
dentist, and I didn't have any.
Write this down.
Same.
Are you writing these down?
No.
Okay.
Yes.
Relative max here, absolute max here. We have no minimum at all.
Not a minimum. 'cause
Okay.
it's an
What?
open
Not a
circle.
minimum because it's open,
It's
open
open.
circle.
I'm not
One,
at.
two,
On
On the right side one. Open circle. Closed circle. Closed circle. Absolute,
Wait,
relative.
wait,
Not a minimum.
Wait, okay, that's what I was asking before.
Yes.
If that's there, why is that not a minimum? Because it's less than that.
What are you talking
And that's not a point. If that's not a point, why isn't that a minimum?
Because it's a high point relative to all the other points around it. So, like, relative to the ones that are right next to it, it's up. Okay? All right, moving on.
I don't know.
Okay. All right, here we go. This is how
Quit
this relates
reciting
to
your
derivatives. Stop. This is how this relates to derivatives.
Preamble.
Relative, extrema, and critical numbers. When we are solving for derivatives, we will find things called critical numbers. Your critical numbers will include your left and your right endpoints.
That's great. Endpoints.
Okay? Critical numbers always include your left and your right endpoint, which they will tell you. They'll say this is where the left side is, this is where the right side is. Your left and your right endpoints are critical numbers. Also, critical numbers occur at maximums and minimums, okay? Now, let's talk about maxes and mins. We can locate a maximum or a minimum without graphing the thing, and this is the most important thing of what we're going to learn today, okay? We can find maxes and mins by looking at the equation and not by looking at the graph, okay? Here we go. Let's say we have, right here. Let's say we have this function. Okay, I know the graph of what it looks like, but let's say we're trying to find the maxes and mins without graphing the thing. Okay,
Derivative.
without graphing the thing, okay?
Derivative.
Now, if I look at this original function and I find the derivative of it, right? Okay, what's the derivative of that
3x
thing?
squared minus 6x.
Okay, 3x squared minus 6x. Okay, write that down off to the side. That's the derivative of this function. Got it? Okay,
3x squared minus
the derivative. A derivative equals the slope of a tangent line, right? Okay? Now, if we look at a maximum or a minimum, these 2 points right here, what's his, like, derivative line going to look like?
0. Hello.
It's going to be horizontal, horizontal.
plug 0
Okay,
in.
so 0 is what the derivative will be, right? So what I do is to find the max and min, I set the derivative equal to 0 because I want to know where his slope is 0. I want to know where the horizontal tangent line is. Yeah.
I dialed
Okay.
911
So-
right before she
Okay, so we found the derivative, set it equal to 0. That's going to tell me my maxes and mins.
Let's
Shush.
pull a 3 out.
Shush. Let's pull a 3 and an x out.
You don't need
Oh, yeah.
3x, so x
Okay.
minus
Minus
3.
x minus
minus
2,
2, excuse
yeah,
me.
equals 0. Okay, so now I set each piece equal to 0. So if I set 3x equal to 0 and x minus 2 equal to 0, here I divide by 3, so x is 0. Here I subtract or add the 2 over, so x equals 2. Okay, now let's look at the graph. Let's confirm with the graph. Do I have a maximum or a minimum at 0 for an x
Yes.
coordinate right here? Do I have a maximum or a minimum at an x coordinate of 2?
Yeah.
Yeah, right
Yes.
there. Okay, so
So
the
you plug
reason
0
why
and 2 in. To
figure out the y
for
coordinate,
your
and you
y.
can see which one is higher or lower. Hey, look at that. There you go.
Extra chapter 7 packet.
For a review. Go see if there's one up in the stats thing. Otherwise, I'll have to run you a copy. Okay. Find the value of the derivative at each. Okay. At each of the relative extrema. Okay. Let's go ahead and take this guy and let's find his derivative. Is this the one that we just did? No. Okay. Find his derivative. 3x squared. One number 1 down at the very, very, very bottom.
Minus 3.
Okay. 3x squared minus 3. We're going to set him equal to 0. Okay. Where are the maxes and mins located? Let's...
Just plus
we
the 3.
could just add the 3 over. Yeah, that's fine. So 3x squared equals 3. Divide by 3. So x squared equals 1. What's the square root of 1?
Plus and minus 1.
Plus and minus 1. Okay, does he have a maximum and or a minimum at positive
Yes.
1 and 1 at negative 1?
Yes.
Yes.
Yeah.
Okay. Now, why do we set him equal to 0?
Because at 0, that is where
Because
the relative
the
maximum.
slope is 0 at that point, right? The
Yes.
derivative or the slope of the tangent line is 0 at that point. Okay. All right, let's do number 2.
I don't like this.
Wait.
That's
So all we have to
not
say for the
zero.
answer is 1?
that zero?
Plus and minus 1?
Plus and minus 1.
That's find the
Fi-
value of the
well,
of
okay,
the derivative.
so yeah, I'm getting a little ahead of myself. Find the value of the derivative at each relative extrema. They're saying,
Just the derivative.
what's the derivative here and what's the derivative here?
So
Here's
3
your
What is
Squared
what is the
minus three.
derivative here and what's the derivative here?
3x squared minus 3.
No, what's the derivative here and what's the derivative here?
Squared minus 1.
No, what's the derivative here?
One.
and
Since when did I
Negative
get
0.
Ow.
That's all we have to put?
Yeah,
It appeared.
Yeah.
Oh, okay.
yeah.
never
So
put that on.
I did it backwards. I solved
Yeah,
for
she-
those
she
things
put it
because
in.
we already know that the derivative should be 0.
So like 1
Okay.
is 0. The value of the derivative indicated the extreme 0. Find the value of the
Sure.
derivative.
Okay, number 2. Number 2. Rachel said no, number 2.
Does not exist.
Why not?
It says it.
Oh, yeah,
Why does it not exist? Why can I not find the derivative at this point?
Because
can't
there's
find
no.
derivative.
It's a sharp.
Because you can't find the derivative at a tippity tip,
Tippity-tip.
right?
Yeah.
Can't find the derivative. Now, if it would have asked for like the derivative here, I could find the derivative, right? Okay, I could find the derivative over here, but it's continuous.
No, what is the dot called? The tippity tip.
A cuspid.
It's a cuspid.
It's
Oh,
a
I hate
cuspid.
that word.
Okay, so
Cuspid?
that tippity tip, you cannot find the derivative
Have you been to the
of things there.
cuspid
So
of
this
Mount
one does not
Everest?
exist.
No.
D&E, kind of like a livet thing. Okay,
Mount Everest.
good.
Yep, we're good.
All right, definition of critical numbers. 2 things that are critical numbers. We've already written them down. What are they? Don't look back.
Shh.
Shh.
What?
Critical
I
numbers.
told you she was gonna hit me.
What 2 things make up critical numbers? Don't look back. Shh.
Max and mins.
Maxes and mins, okay?
Left and right.
Those are
front.
critical
And
things.
Left and right.
And left and right endpoints, right? So those are things we're looking at, okay? Maxes and mins and endpoints,
back.
I'll say.
What if it doesn't give us the
And
endpoint?
points, it has to.
Don't look back. No, on number 2 it doesn't.
What
Find the critical numbers.
Then you're just finding maxes and mins. Yep. Okay, relative extrema only occur at critical numbers, so you're only focusing on critical numbers. Here we go. This example, and then we're like almost done. Here we go. I did a little box for you to like, make it easier. So we have the left endpoint, we have the right endpoint, and we're finding extrema. So we're on the middle example right here. We have the graph of what he looks like, but you won't on your homework assignment. That's just to confirm our results. Here is the function that we have, and the interval is -1, 2. So my left endpoint is -1, my right endpoint is 2. Now, that is -1, something, and 2, something. That's the y coordinates. Like, it's just saying those are the x coordinates,
So
right?
wait, if we put it into the formula, we can find the y coordinate.
If we put it into the original function, we can find the y coordinates. So if I plug -1 in, 3 times -1 to the 4th minus 4 times -1 to the 3rd.
3
okay?
plus 4.
Be 3 plus 4, which is 7. And is that consistent with the graph?
Wait,
Is
what
it
just
-1,
happened?
7?
I have no
We're plugging -1 into this function to find out what his y coordinate is at that point. Okay,
Oh,
got it?
okay.
All right.
16.
Okay, next.
There's a cuspid.
Next, the right endpoint, if I plug 2 in, 3 times 2 to the 4th power minus 4 times 2 to the 3rd power is 48. Check me. minus 4 times 8 is 32, which is 16,
Yep,
2 comma 16. Okay, we're going to use those y coordinates in here in a second to tell us things. All right, we need to find the other critical numbers that are in the middle, which are found from the what?
Derivative.
The maxes and mins, the derivative, right?
12x
Max
to the
slash
third.
min. Okay, so let's find the derivative. 12x to the third
12x to the second.
minus 12x to the second. All right, equals 0. We set them equal to 0 to find the max and min. Then what are you going to do?
Pull out a 12x.
Pull out a 12x
X
squared.
squared.
Yep. Left over,
X minus 1.
x minus 1 equals 0. Okay, if I set 12x squared
I'm
equal to 0,
severely
0
lost.
and 1.
okay, I'm going to divide by 12, divide by 12, x squared equals 0, and the square root gives me just 0.
Hey, whoa.
Okay.
Whoa.
And here,
0 and 1.
and 1, right? 0 and 1 are going to be my critical numbers.
Don't know
Yes.
how you got that at all.
We
but
took the derivative and set it equal to 0 to find the maxes and mins.
Do you plug your critical numbers back into your derivative
Yes,
or the original?
into the original to find the y coordinates.
Oh,
So
into the
good question.
original,
Yes.
okay.
So 0 is my critical number. There's something important happening at 0. It's either a max or a min. There's something important happening at 1, and if I want to find the y coordinate for that value, I'm going to plug that into the original to find the original y coordinate value. So if I plug 0, what do you get?
0.
0, 0, 0, right? If I plug 1 into the original function, 3 times 1 to the 4th minus 4 times 1 to the 3rd. Can you do that kind of in your head? -1, okay? All right, now, the reason why we filled in all of the y coordinates, to make it really nice, which one is my absolute maximum?
0, 0.
No.
216.
Or
216 is an absolute max because your
Highest
end
number.
points on a closed interval could be a max or a min, right? Which one is my absolute minimum?
1, -1.
1, negative
Yeah, right? Now, the other ones I don't necessarily know if they're maxes or mins, right? Because they could be, either one. But I can tell absolutely the lowest point and absolutely the highest point on my graph. Is that consistent? Absolute max here, absolute min here, right? We just said that from the chart. And I did that without having to graph any of that, okay? All right, let's do one more. Here you go. I went ahead and gave you what the derivative looks like because when you're taking the derivative of an absolute value, it's kind of icky. It's kind of like a chain rule thing, okay? So we'll talk about that more specifically later. But I'm going to do the box thing again because that's helpful, okay? So I'm going to do a left endpoint, a right endpoint. Now, here's the deal.
You can't
Left, right, okay? My left endpoint is at -2 comma something. My right endpoint is at +2 comma something. Do you see where I get that information from? Here's my stuff. Now, I have no idea how many critical values I have in the middle. No clue. I don't know how many critical values I have in the middle. So I'm just going to leave a big open place. Maybe I only have one critical value,
Hopefully
right?
it's 2.
Maybe not. I don't know. We'll see, okay? So these critical values, critical numbers, okay? I don't know. Maybe it's 2, maybe it's 3, whatever, right?
so
We get those
tired. I
critical
don't know
numbers
why.
from doing what?
Backpack in my.
Plug in the number to the equation.
I know, but I just
What?
realized.
Plug it into the
needed
equation.
stuff out of my
Plug what into the
backpack.
equation?
Your X.
No.
The endpoint.
Oh, you're trying to find the
I
y
need a
coordinates. Okay, let's do that first.
folder.
So if I plug -2 in here, if I plug -2 in, 1 minus -2 squared, we're trying to find the y coordinates first. That's what Marcus wants to do. So this would be 1 minus 4 and the absolute value of that.
3.
Positive 3.
+3. Okay, is that consistent with the graph?
Damn.
Yep. If I plug a +2 in here, it should be the same. 1 minus 4, absolute value of that is also +3. So that's where they get these max and min points from. That's consistent with the graph. All right.
Critical number.
Critical numbers. How do I find those?
Find some
These are like the maxes and mins, right?
So
How
the
do I find
derivative.
maxes and mins?
Find X of derivative.
Derivative equal to 0. They're giving me the derivative. They're saying this is the derivative, so they've already done that for us, and it's
That's
already equal to 0. Okay? All right. What are you going to do now?
Multiply the -2x over.
No, he's already on the top.
Plug it
Or
in.
divide the 2x over. -2x over.
Multiply
Okay,
1 minus
so
x
let's do
squared.
this. I'm going to go over here. And I'm going to say rather than writing it the way that they did, the -2x is technically in the numerator, correct? Okay, so I'm going to put him up with the
It's
numerator,
all of that
right?
over the
-2x is like over 1. He's
Dude,
technically in
just
the
say
numerator. Then
equals
I've got
0.
this.
That goes away.
Okay, I've got the absolute value on the bottom and the 2x's on the top,
So
right?
can you multiply by the bottom?
Can you multiply by
0?
the absolute value? You sure can. So let's times the absolute value. 1 minus whatever that is. Okay. He goes away. 1 minus x squared. The absolute value of that goes away. This times 1 minus x squared. If I multiply the absolute value over to 0, it's 0, right? So now all I have left is this. Whoop, whoop, equals 0. Okay, I have this, just this stuff. That's stuff that's still on the top.
You have
Those two
negative
things
2x
multiply
times
together.
1
Okay.
minus x squared.
Okay, got it? Yes? Okay, now what?
So
How do I solve?
Distribute the negative.
take
I don't wanna
out
do that.
a.
He's already in two pieces. Let's just set negative 2x equal to 0.
Oh, I get you.
And 1 minus x squared equal to 0, right?
Okay. No.
Yeah, right? Like we factored him, he's already factored down for us.
Sure.
Okay? If negative 2x equals 0, let's divide by negative 2. And x equals 0, right? That's one of my critical numbers, right? What do you want to do with the other one?
And subtract the 1
No, I don't want to do that.
and divide by a negative.
Add
the
and
negative
take
way.
the
I'm going to add the
square
x squared over, Emma. 1 equals x squared. Then take the square root.
If
And
you
that
think
is-
about it,
Plus
it's
or minus
exactly the
1.
same thing.
It is, you're right. You just are crazy.
It's
So how many critical numbers do I have in the middle?
3.
3.
I don't have enough room for 3.
Girl.
Holy crap. 3 critical numbers. All right, the one on the left side, which one's the one that comes first? If you put them in order, your critical numbers in
0.
order. Nope. Critical numbers in order.
-1.
Negative
-1.
1, comma something. Then
0.
0, comma something. Then
1.
1, comma something. Okay? How do I find the y coordinates that go along with
Plug
those?
it in
Plug it in where?
The
to the original
To
equation.
the original one, right? I'm trying to find the original y's. Okay.
0.
1 minus negative 1.
Sadness from Kyle.
Okay, 1 minus negative 1 squared is
0.
1 minus 1, which is 0. Negative 1 is at 0. Or if you look
1.
on the graph, that's what it is, right? Emma's cheating. And look,
0.
is Emma cheating and looking at the
No,
graph?
I'm solving it.
You are literally plugging them in. So if I
I'm
plug 0
literally
in,
plugging them in. It's
I get 1. Okay,
And
if
that
you plug
one's
1 in, that's going to
0.
be 0 again. Okay, so
Ungle.
what's my absolute maximum point? Absolute maximum point.
2, 3.
Negative 2, 3.
Negative 1,
and 2,
0.
3.
Yeah, there's 2 absolute maxes, right? There's an abs max here.
Wait,
Oh
what's
my
0?
goodness.
And there's an abs max here, right?
1?
The highest point
0
has
and
the
0.
highest y coordinate, okay? The minimum point
That doesn't
or points,
That's one.
what's my absolute minimum point?
0.
0, right? 0 and 0, these two have the lowest y
0.
coordinates, so this is an absolute minimum. And this is also an absolute minimum.
Now let's
So
do
we can find the absolute highest points and the absolute lowest points by not even graphing, by just looking at
I'm
derivatives
lost.
and left and right
What's our
endpoints.
lowest one?
0. Like the negative 1, 0 and the 1, 0, because 0 is the lowest y
Yeah, we
coordinate.
have
Okay.
2, don't we?
Yeah, we have 2 absolute. So we have 2 absolute maxes and 2 absolute mins.
Yeah.
By looking at the graph, are these 2 my absolute maximum points? Are these 2 my absolute minimum points? Yes, they are. Okay,
Do we
good.
have to say that on our thing?
If they ask for it, yes.
Well,
When it says
I'm so
find the
tired.
absolute extrema of the function, that's like number 4.
But when it's just
Yep.
critical numbers.
When it just says find the critical numbers, you don't have to plug them back in and figure out which ones are high and low. Okay? You're just trying to set the derivative equal to 0. Okay? Got it?
How do you do number 1?
Yeah. How do you do number 1? I don't know.
Plug it in.
Find. Oh.
I don't understand.
You just have to
I
find the
don't-
absolutes, or do I have to find the relatives?
No, you can't find the relatives using
Well,
this
that's what I
process.
could have.
No.
what
Well,
it
you
looks
don't
like.
necessarily know that that's a maximum, though. It could be a relative min. It's a
Well, I know
relative
what it looks
something.
like.
Okay, well, yeah, because it's an x squared. But yeah, I mean, yes. Well, if it's not an absolute max or a min, it's a relative something, but you don't necessarily know if it's a relative max or a relative.
Okay.
Okay. So number 1, find the value of the derivative of the following functions at each indicated extrema. What's the derivative of this thing?
3
over 2
over
x
2
to the
minus.
Do we have to know that?
3 over 2 x
plus
squared
1 plus
minus 3x, and then that's it, right?
Yep.
Okay, that's my derivative. Okay.
Minus
It says
3x.
find the value of the derivative at each extrema. So my
0.
first extrema is 0, 1. I'm going to plug 0 in for x, right? 0, 1 is 0. If I plug that in, what do I get?
0.
0. Why do I get a derivative of 0 at this spot?
Because
Because the slope of his tangent line is 0, right? Okay, if I plug 2 in to the derivative,
2
3
squared,
over 2 times
4
2 squared minus 3 times 2.
over 2, that's 6.
I bet it's 0.
4.
Minus
gonna
6,
guess.
that's 0.
6 minus 6, 0.
Which is 0. Why is the derivative 0
that's
at
The
this
slope is
point?
tangent
0.
line is 0.
Because the slope of the tangent line is 0. They're just showing you that like maxes and mins, the slope of the tangent line is 0. Always, always, right? Okay. Critical numbers. Find critical numbers. That means find your maxes and mins. Okay. You don't have to plug them back in and figure out which ones are the
Well, we
absolutes
got
and
no
relatives. You
point.
just have to find your x's. Find the critical number, set the
So
derivative
we
equal to
set
0.
it equal
Okay.
to 0.
Oh, the derivative.
All right. Absolute extrema. I would do the little box thing for number 4 and number 5.
Comature, I'm confused.
Okay. I would do the little box thing. Okay. So do your boxes for the last
I don't get how to do
Take
2.
out
4 through
A.
7. Do your box thing.
How
Okay.
do you do
3x.
2?
Then you get x.
What?
How do you do 2? Do you
Minus
supposed to
2.
separate it?
No. Find the critical number. So you
One,
just,
you were doing one on there and
X
you like
equals 0,
separated
X
it into
equals
2
2.
things.
what do you mean? You just break it down. So like this right here. Is there something that you
Did you get
can
0
pull
and
out?
2?
There you
Are you
go.
supposed
Pull
to-
something out.
I'm supposed to pull something out?
Sure. Why not?
How do I do this?
3x.
3x. Take a 3x out. Okay.
3x.
All right. There you go. I'm gonna stop the
Wait,
recording.
so you said